Welcome back to the second part of the paper 22 May June 24. This is question number 4. This compound exists as pair of stereoisomers. Uh, Draw the three-dimensional structure of the two stereoisomers of this compound. R can be used to represent this. So this part is used as a AR. So three-dimensional structure. So this is C, this is carbon, and we placed R over here, and these are on the plane. These two molecules are on the plane, and this is in front of you by drawing solid wedge, and this is away from you. That is Br. So draw another molecule which is optical isomer of this, mirror image of this. So you can draw like this. This is dotted wedge. This is solid wedge. This is towards you. This is solid wedge. H, and this is CH3. So these two molecules are mirror image of each other. Now next question, B part, a sample of this compound react with sodium hydroxide to make alcohol in an SN1 mechanism. So this is nucleophilic substitution. This is SN1 complete because this is tertiary. Secondary isomer. This is secondary haloalkane. So SN1 mechanism. Complete figure 4.1 to show the mechanism for the reaction of these compounds and sodium hydroxide include charges, dipoles, lone pairs of electrons. So this is electronegative. Bromine is electronegative, carrying partial negative charge. Carbon become partial positive, and bromine is electronegative, attract like pair shared of electron towards its center. Draw curly arrow, and now you have to draw intermediate R. This carbon become positive because bromide is leaving now, leaving group, and CH3 because nucleophilic substitution. So OH, draw curly arrow on this. So this compound is formed. Separate samples of haloalkane, alcohol, and this is alkane. This is alkene double bond over here, and this is secondary alcohol. This is secondary alcohol, and this is secondary haloalkane. And this is alkene. So bromine in the dark, so you know that bromine liquid in the dark, and observation with this compound, say there is no reaction, and no reaction with this alkane chain because bromine can react in the presence of sunlight. So no reaction. And this is double bond, so bromine decolorized the no, sorry, this alkene decolorized the bromine water. So the observation would be brown to colorless. Bromine is brown in color and alkene decolorize this bromine brown to colorless. So this is PCl5 and this is alcohol. So PCl5 react with this alcohol to form haloalkanes and steamy fumes of HCl. So the observation would be steamy fumes of HCl. Silver nitrate. So this part of the compound react with silver nitrate to form silver bromide. So the observation would be creamy precipitates are formed of silver bromide, and there is also no reaction, and PCl5 also cannot react with this part of alkene, so this is also no reaction. So this the D part of this question is this compound is heated with D to produce three different molecules EFG. This is a three different molecules is heated with D. What is D? Is heated with D. So heated with D to produce three different molecules of EFG. So this molecule is bromine over here. So when it reacts with D, this bromine is going to replaced and forming double bond. So this is in the presence of the reagent would be the sodium hydroxide. The D is the sodium hydroxide in ethanolic medium, in ethanol. So the bromine is replaced and double bond is formed. So this reaction, name the type of reaction. So this is the isomer of this is F and this is G. So this is E produce three different molecules EFG. Name the type of reaction. This is elimination reaction because bromine is going to eliminate, and that identify D. D is the sodium hydroxide in ethanol, in ethanolic medium. Both sigma and pi bonds are present in molecule of E as a result of different types of hybridization in the carbon atom. Complete table 4.2 to show the number of carbon atoms with each type of hybridization, sigma and pi bond. So this is carbon and this is carbon, this is CH3, this is CH2, CH2, CH2 and CH2, CH3. So there is no sp hybridization, so double bond is there. No sp hybridization, sp2 where double bond is present, so sp2 hybridization is there. So there are number of carbon atom which undergoes sp2 hybridization. So this is carbon 1 and this is carbon 2 which are undergone uh, sp2 hybridization, and rest of the carbon atom, this is one carbon atom, two, three, four, five, six. So six carbon atom undergoes sp3 hybridization. So two molecules undergone, sorry, not pi, two molecules, two carbon atoms with two carbon atom is sp2 hybridization, with a six carbon atoms are sp3 hybridization. So because double bond, when double bond is there is one s2p hybridization. So that is sp2 with two carbon atoms. So there are two double bond with two carbon atoms. So this carbon atoms has sp2 in this, and rest of the carbon has one s 3p, that is sp3 hybridization. There is no sp hybridization in this compound. So two carbon atoms undergoes sp2 and 3 rest of the carbon atoms undergoes sp3 hybridization. Describe the essential feature of an unbranched hydrocarbon that causes its molecule to show stereoisomerism. Explain how this feature leads to the stereoisomerism. A carbon have a pi bond. There is a limited rotation about carbon double bond. Also, there should be two different group on each double bond carbon atoms. So there is double bond carbon having a carbon have a pi bond, and there is limited rotation about the carbon to carbon double bond. Also there should be two different groups on each double bonded carbon. For example, in this molecule, look at the E. So this carbon atom, for example, there is double bond C, these two carbon atom H, and this is surrounded by CH3, and on this, if we represent this carbon, so 1 2 3 4 5, so C5 H11. So this is, we can represent this group R. So there is limited rotation around the each double bonded carbon, and each double bonded carbon uh, has two different groups, CH3 and H, and on this side hydrogen and C5H11. So this is also has cis trans isomerism. So there are two conditions which are required uh, required for possibility of stereoisomers. So carbon have pi bond, and there is limited rotation about carbon to carbon double bond, and also there should be two different groups on each double bonded carbon atom. On each on double bonded carbon atoms. So there is question number 5. Compound W has a molecular formula C4H10O. It contains only one functional group. Table 5.1 shows the two peaks with the greatest mass over charge values in the mass spectrum of W. So 74 is the relative abundance of this MR is 50, and this is 75, or this is X. So the bigger molecular mass is represented with M plus 1 peak, and this is M plus peak. So we have formula is how to calculate the number of atoms. N is equal to 100 over 1.1 into MA. This is abundance of M plus peak, abundance of M plus divided by M plus 1 abundance. This is abundance of this. Now calculate this by using this formula. N is equal to, we have number of carbon atom 4 into, so X is equal to, now this is N is equal to 100 over 1.1 into M plus abundance, M plus 1 abundance. It is represented with X. So X is equal to, number of carbon atom is 4 into 1.1 divided by 100 into 50, abundance of M plus P. So this is equal to, so X is equal to 2.2. So this is the abundance of X, 2.2. So the mass spectrum of W also shows peak mass over charge is equal to 29 and mass of charge is equal to 59. So we can separate this compound like CH3, because this is positive peak, so positive ion is formed and electron is removed by splitting of this splitting of this molecule. CH3, CH2, 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 O, H. So this molecule 1 is 29, so 29 would be this. We split this molecule fragment into CH3, CH2. This is positive ion, and second positive ion is this is equal to carbon 12 into 2 plus 5 is equal to 29. So this is 29. This is fragment ethyl ion, 2 positive, and this will be 59. 59 if we split like this, and O, CH3, CH2 and CH2O positive ion, and this is equal to 12 into 3 carbon atom plus 2 to 4 and 3, 7 plus 16. So this is equal to 36 plus 7 plus 16. This is equal to 59. So it is C3H7O positive peak. A sample of WC4H10O is heated under a flux with an excess of acidified K2Cr27 until there is no further reaction. Only one organic product X is present in the molecule at the end of the reaction. At the end of reaction is heated under a flux with an excess of acidified until there is no further reaction. So this is alcohol, or this peak would be, this is between this and this is the alcohol peak. Organic product X is present in the mixture at the end of the, so this is A, so A is in between, this is A peak is in between 32 to 36. This is OH peak, this is OH peak, this is the OH peak, 3200 to 36. This is OH, this is wider peak is the for OH peak, and B is the carbonyl peak because it is in between 1740 to 1670 to 1740. So this is carbonyl peak. So A bond is OH bond, hydroxyl, and this is carbonyl peak. Part 2 of this question is C4H10O. Use the information in A and B1 to draw the structure of X in the box in the figure 5.3. So this is potassium carbonate. So carbonyl and hydroxyl group is present, so that it is a secondary alcohol, and secondary alcohol when react with the acidified potassium dichromate, it changes into ketone, though. So the formula is X would be ketone, CH3 CH2 C double bond O and CH3. Y is a structural isomer. Y is a structural isomer of W. Both W and Y products produce colorless bubbles when sodium is added to them. Y does not react with heated with acidified potassium dichromate. Y does not react when warmed with alkaline iodine. So Name the functional group present in Y. Y is a structural isomer of W. If it is secondary alcohol, it is secondary alcohol because potassium dichromate react with the ketone with react with acidified potassium dichromate to form ketone. So Y is a structural isomer of W. Both W and Y produce colorless gas, colorless bubbles when react with when sodium is added to them. So sodium react with when this compound W produces bubbles of hydrogen gas because it is alcohol. So W and Y. Y is a structural isomer of W. Y does not react when heated with acidified potassium dichromate, and Y does not react when warmed with alkaline iodine because Y is primary alcohol, so that's why it does not react when heated with acidified potassium dichromate, and it also does not react when warmed with alkaline iodine. So functional group is alcohol, primary alcohol, or hydroxyl. You can write down hydroxyl or alcohol. Complete the equation. Describe the reaction of W or Y with sodium. Y does not react when heated with acidified potassium. It can be tertiary alcohol. It can be tertiary alcohol. CH3, CH3, CH3 and OH. So that's why it does not react with potassium dichromate as well as with alkaline iodine. So react with sodium C4H10 O Na plus half H2. So this is the chemical equation for this reaction, and structure of Y is tertiary alcohol because tertiary alcohol does not react with acidified potassium dichromate but primary alcohol does. So it is tertiary alcohol. OH. So this is all about of this question paper 2 May June 24 question paper 2 2.